Hello everyone, I'm Suresh Kumar from the Mindrace.ai, a newly launched edtech platform focused on bridging the gap between technology and business, helping professionals build real AI first skills. With the rapid evolution of AI from OpenAI to Anthropic AI and beyond, one thing is clear: AI is no longer just technology, it's becoming a foundational skill. Just like communication or problem solving, AI literacy will be essential for everyone by 2026 and beyond. At the Mindrace.ai, our mission is simple: help you choose the right tech, the right role, and build the right skills for the future. We also built Diti.ai, an IT job readiness and career fitment assessment platform to guide you toward the role that truly fits your strengths. And today, let's begin our first episode understanding how all IT roles actually work together inside an organization. So, in this slide, I'm going to explain something that most people never get clarity on: how all tech roles actually work together in the real world, not as an isolated job title like data scientist, cybersecurity engineer, AI engineer, testing engineer, software developer, right? So on. So, not as an individual title, instead, as a connected system from business idea to the production. Whether you are a student, a fresher, a career switcher, or already working in IT, this video will help you finally understand where each role fits. Every digital product, no matter the industry, could be banking, retail, e-commerce, pharma, healthcare, you name any industry, oil and gas, anything, they follow a simple journey. Based on their vision, the organization's vision, they start with an idea, all right, the product idea. And then they pull all the expertise, could be developers, marketing experts, and so on, and they build it. They understand the consumer empathy, they understand the consumer need, and they build it. Then they start scaling it up based on the feedback, whatever the feedback they get it from the users, initial level of users, right? And then they kind of sell it. So to conclude, every digital product, right? It starts with an idea and they build it and they scale and they sell it. So all these tech roles exist to support each stage of this journey. Today, the IT world feels overwhelming, right? So there are so many roles. So I think broadly 30 plus tech roles exist in today's world, broadly, right? And everyone tells you to learn tools, but very few people explain how these roles actually connect. So that's why many people get this confusion, not because they are incapable, but because the picture is incomplete. So most people learn tools like Python, Cloud AI, DevOps, etc. But they don't understand where these roles fit in the system. This is why career confusion exists. The core truth. So here is the most important truth that you need to understand. No tech role works alone. Every role exists because a business problem exists. Business creates the problem. Technology builds the solution. Once you understand this, choosing the right role becomes much easier. So in this slide, I'll be talking about the tech life cycle, right? Any product, they should follow this flow, right? First, they have to start with a business problem and the research and strategy, design and development, data intelligence, sales and growth, operations, security compliance, deployment, testing and quality. So to give a more detail, understanding, right? Let's pick up a simple example to understand what exactly all these things, right? I'll give a simple recent A app that is launched, I think, which is Smart Care, right? So this is basically AI-powered telemedicine app. Okay, imagine a platform where patients book appointments, doctors consult online, AI suggests possible diagnosis, prescriptions are also auto-generated, and follow-ups also automated, right? So this is the problem they've recently launched, Smart Care telemedicine app. So let's understand each and every flow, the part of this life cycle what we just discussed, right? So what is the business problem here? The business problem is rural patients lack access to the specialists. That is the problem that I want to solve. What sort of research I have to do and what sort of strategy I have to build before I go and build my product. So we have to do some market research, which shows like 60% of rural patients. This is in general, right? I think we know that most of the people they travel more than 50 kilometers to consult a expert specialist. That is what actually they found through research. Now, what sort of design they have to come up with? The UX team. So these things, all the roles I will be discussing in detail in coming slides, right? So for now, I'll just give a brief. A simple patient app, right? And the doctor dashboard, or maybe like AM symptom checker, etc. So some simple things they can think of to put in design. And what sort of development? It could be an app or web-based. They can use tools like React, backend APIs, appointment scheduling engine, etc., etc. So data intelligence, right? So data engineers builds the pipeline, data scientists build symptoms prediction model, AI engineers integrate LLMs and also the LLM based medical assistant. So this part is crucial. So what sort of design and how you develop it and how do you deal the data intelligence part, especially data science and AI comes here in this part, right? So then we have to test the product once it is built. So whether it is working fine or not, the testing team will take care of it. And once the testing is done, how do you deploy it, whether it is Azure, AWS, GCP, etc., right? To auto scale enablement also considered. Then security and compliance, this is very, very important because you are dealing with the patient's data. So you have to make sure that it is compliance and also patient data gets encrypted, right? And also you have to give a role-based access control, all these things. Then operations, look, you have to keep monitoring the mm, time, how it is actually functioning, the application, the accuracy of the model that you're putting it in the in the data and intelligence part, right? And the time, the response time. When a user is interacting with the application, how much time it is taking to give the insight or respond to the user. Then that is actually about operations. The last one is sales and growth. So where you can think of a marketing expertise. They're actually running the campaigns to make sure that the need persons, the users who are in need can actually leverage the benefit of the smart care. Now, a simple example, right? So now hope you understand at a high level. So how a product can be built. First, you need to understand what problem that you're solving. So don't directly jump into the solution. First, you have to evaluate the problem, whether the problem is really, a valid problem for me to solve or not. Then do a proper research, then pull your expertise, like what sort of design, how do you develop it, what sort of intelligence is required for your product, then do proper testing, deploy it, and make sure that it is, running up during a peak time when user penetration is very high, and make sure that the data is securely saved because it's patient's data, it's personal information, right? And continuously focus on your growth, sales and growth. So this, whatever roles we initially discussed, 30 plus tech role, right? All these roles fits either of these functions or sub functions, right? How and what is the tech stack, the 2026 that we have to, expedite to make sure that to fit into either of these roles, we'll discuss in detail. Let's start with the first one, phase one, business problem, right? So everything starts with the problem. For example, if you consider the banking industry, right? So let's say loan approvals are slow, or fraud losses are increasing, or the conversion is dropping, right? So at this stage, there is no coding, there is no tool. When I say tool, programming language or coding, no architecture, right? So only the question matters is what is the problem and why does it matters to business? So this is the only key thing here, right? So for example, business leaders identify problems like customer drop-offs, rising fraud losses, etc. Right? So what we do here, so we kind of use some tools like could be, Excel, could be Power BI, right? So there are so many industry reports are there, CRM dashboards are there, Confluence is there, SharePoint, so many tools are there. So these things are, you don't need to spend time and money to learn, but it will come eventually over the experience. So, and who are the people who involves here is business stakeholders, domain experts, and the strategy teams, core business team. So they try to identify what is the pain point here. And if I bring previous example, right, the AI medicine diagnosis recommender app. So they're the pain point they identify, they try to map the empathy, and they define how do we success, how do we measure whether our solution is meeting the problem or not, what sort of constraints we should have, all these things. I've given a couple of simple examples here you can see here, like customers are dropping during onboarding, reducing conversion rate by 40%, decreasing sales in a portfolio, what is happening here. So these problems, right? So when they come, the expert team will start analyzing it and come up with a solution. Could be through a ad hoc solution or could be through a digital product. So this is the first part. So let's move on. Okay, now let's discuss about the next phase. User experience and user interface design, right? UX and design. So once the problem is clear, the designs begins. UX designers focus on how users feel when using the system, wherein UI designers focus on how it looks. So they basically ask these questions like, where does the user get confused, right? And where do they drop off? How many clicks are too many? So these sort of things they do think and then come up with the design and flow. So a good UX can make an average system also successful. A bad UX can kill the great system. So this is the myth. This is reality, right? So if anyone wants to get into this UX and design space, so make sure that you should put some creative thought process and help people to get the best user experience and user interface. A UX designer redesigns an onboarding flow to reduce the number of steps from, let's say there were 10 screens, right? So the best UX designer should cut down that to 5 or 4 screens so that the journey will be more smoother for consumer to experience the product. Similarly, the UI designer so ensure that the buttons, the fonts, and the layouts are consistent across the product. Could be web or mobile app. So these are the few tools like so Figma is one very popular, and then you can try Adobe Suite, Adobe products that are like XD is there, and then Illustrator is there, and there is one more thing called Maze. So these are few tools. Okay. So this is the output. So the output from phase two is, so they have to give this design to the developer, right? What user journey, wireframes, screen flows, and interactive prototyping. So this is about UX and design part. Let's move to the next one. Let's move to the development part. So far we discussed business problem and strategy phase and UX and design phase. Now it is development phase. So the front end side, front-end developer and web developer are primary the roles involved in any industry. Like what they do is they try to, build the screens. Suppose if you enter Amazon.com, right, website, whatever the front end that you are seeing, that is actually the UI screen, right? So these guys, they build these two, the UI screens and the forms and input validation and dashboards and the interactions. So these are the key programming languages I could say, which are popular right now in the industry, like React, Angular, HTML, CSS, or JavaScript. So if anyone want to become a front-end developer, so make sure that you expertise on these programming languages, right? And practice this to pick into either of these roles. Let's move on to the back-end development. Okay, so we discussed just now the front-end developers, or they build what users actually see, the screens, the buttons, the forms, and the dashboards, right? So when a user clicks apply loan, for example, or submit order, so what it do? So it will take all the data, whatever the user is giving as an input, and it will push into the backend part. So the backend development, these guys, the backend developers, basically could be a backend developer or a API developer. They build the logic behind the scenes. They handle rules like, who is eligible in the same example, what validation should we apply, which system should we call next, what sort of predictive model should get triggered for this particular question. So in a layman language, the front end asks a question wherein the back end decides the answer. So always there is a connection, or I could say a pipeline built between the front end and the back end developer, right? So a back end developer implements all the rules using, and if it is a simple logic or it is a predictive model, anything, using tools like, Java, Python, Node.js, REST. It depends on, right? Fast API is very powerful, especially, if you want to reduce response time and if you want to call, right, AI-based models, right, which is very popular. So if anyone wants to get into this backend development or, API development, try to focus on these programming languages, right? I hope you are clear between, the front end and back end. Now let's move to the next one, which is mobile development. Okay. So the mobile developers, they specialize in either Android or iOS platforms, right? So they handle performance, device compatibility, notifications, and offline behavior. See, try to understand the difference, guys, please. The development, could be a, offline product, right? So there is no web involvement, or a web-based product, or an application where user can download it from the App Store. Could be Android or iOS platform, for iOS platform, right? So in many industries today, mobile is the primary channel, right? Not the desktop. So it is important, whoever is, wants to become a developer, make sure that you understand the tech stack, or I could say programming languages on this mobile development as well. So these guys, they build secure Android or, iOS apps with push notifications and offline support. So these are the key programming languages, I could say. So React Native, Kotlin, Swift, Firebase, especially for Android or iOS developers. Cross-platform is basically a person who can handle both on Android, iOS at the same time, web and mobile as well. So who are expertise in either of the, mobile development and also the web-based development. So sometimes, you have to build a web-based product which is mobile friendly. Instead of an application, it should work in a way, the same way how it is actually functioning on the website. That is about mobile development. And now let's discuss the full stack development. So wherein we discussed so far front end, back end, and mobile development. So the full stack one is basically uh, work across front end, back end, sometimes databases as well, right? For example, you are a graduate and you want to test whether you are eligible for a admission into a university, let's say, right? So you enter all the details of about your graduate score, your CAT, whatever gate or GRE score, etc. Then in the back end, it stores into the data set and you try to pull some machine learning and then give an output saying that what is the probability that you will get admission in so and so university. This is a simple example. So for that, a person should have all these skills, right? So they should understand what is the front end requirement, the inputs and stuff, and the back end logic, API calls, and the database system as well. So there is a popular database called file store, so Firebase or file store. They should have basic understanding of that as well, right? Full stack does not mean doing everything alone. It still works inside the same life cycle, but yeah, it's good to have tech stack. It's UI, APIs, databases, and complete software products. That is about full stack development. This title is very popular these days, right? So, but yeah, choose wisely whether you want to go for a full stack developer or a full stack or a front end. No, not full stack, just front end or a back end or only mobile. So based on your passion, try to pick. So mostly startups, right? So where they want to build some products, they actually hire for this full stack. This is, I have one simple example. You can see what the tech stack actually is. So now let's discuss the data part. So data and AI part. So whatever we discussed, right? So the front end development and back end, or before that UX, everything. This is the core part. On top of all these, very important thing is how best you are actually managing your data. So this data and AI is crucial. Now, these days how every industry is try to adopting AI. Further, data is crucial. On top of it, how to manage my data and how to engineer it to make sure that the data analysts, data scientists, and AI engineers can leverage uh, data and give the best value, get the best value out of it, right? So this is the first role in data side, I could say, data engineer. This guy, data engineers, basically, they are the foundation of all analytics and AI. They build pipelines, they build ETL jobs. Of course, the pipeline is to run the ETL job and then streaming the data and how to design the rules for the data streaming, etc. If data engineering is weak, whatever analytics you built on top of the data becomes unreliable and AI becomes useless. So this role is invisible but absolutely critical. I could say this role exists forever, data engineering. And this is very, very crucial, important in any organization. A person who can design the data role to make sure that the data is storing properly so that the analytics AI teams can leverage it to generate the value. Okay. So these guys, they build pipelines that move data from applications into the central data warehouse. Take a simple example, right? So suppose if you're entering Amazon.com, you enter your email ID, you enter your password, etc. Then you give some data, like while you are signing up. So when the moment you send enter, right, this goes to the central data repository. Could be on Amazon Web Services S3 storage, right? So this particular thing, right? So how to get this data and what sort of rules to get validated before they store into the data. Here there is a lot of stuff is there, guys. If anyone become want to become a data engineering guys, you have to understand data lakes, data lake house, warehouse. So many things are there. A very, very, very important role, data engineering, and even it is a structured data like like name, age, salary, etc., or unstructured. These days, you know how much unstructured data is becoming, right? Reviews, sentiments, like feedback, a lot of text is available. So either it is a structured or unstructured, still a data engineer rules how to get that and get stored into the central data warehouse. Okay, so there are very popular, of course, like few years back it was Hadoop was very popular. Now I think it's Spark. I could say PySpark. Spark. Then there is this Apache Airflow is one popular tool, and then Snowflake. So this is very, very important. Snowflake, and there is a tool called Data IKU. There are so many platforms are also coming up like Databricks, etc. These are very popular if you want to become a data engineer to get hands-on expertise on it, right? So that's about the data engineering, right? So let's discuss about data analysis and business intelligence, right? So these guys, they answer one key question like, what happened and why did it happen and what are the trends basically to business leaders, rely on these guys to understand performance of the business. So primarily we have two roles like data analyst or a BA developer or BA expert. Different organizations use different nomenclature, but yeah, at high level this is the purpose. So once we get the data from the data engineering team, so we have to put in a proper reporting stuff wherein business can see what might have happened, how many consumers or what number of consumers have actually logged in today, right? And what is the total dollar sale that I'm actually getting on month over month. So these sort of key things that they built. Like I think very popular tools like Power BI is very popular these days. Microsoft Power BI, and also there is a Tableau is called. There are so many BI dashboarding tools are there, so you can explore. Excel is one. Of course, SQL also you can do to aggregate your data from the raw data to aggregated data, and then put it in Excel and put a nice chart as well. Right. So these guys they build executive dashboards as well for leadership decision making. So very key thing because this gives a direction for data scientists to come up with the analytical problem design, right? So if they get to see that okay, significantly there is a decrease in number of consumers that they are logging in, or dollar sales are decreasing, how best we can come up with what are the drivers actually making this decline. Okay, so data analysis, data engineering, and data scientists, all three functions, work closely because they highly rely on data, and data engineering has to is responsible to build accurate data, right? So this is about data analyst. Let's discuss about data scientist. So we discussed about data engineering and data analysis. Now let's discuss about data science. So these guys, go one step further. When you compare with data analysts, so now they ask what will happen next, right? So they build models to predict the future, and they do segmentation of the consumers so that they can get the best targeting strategies, and they do optimize the resources for the business so that business can control the cost and time for their activities or operations, right? And they do detect the pattern, and they try to control the loss or damage. So these are few use cases. And importantly, the whatever prediction and whatever could be a churn prediction or risk prediction, and or a next best offer for the consumer, all these things, right? For that you should have proper data and do a thorough data analysis. So if you do a thorough data analysis, you get to see uh, the relationship between different features, like sale, transactions, promotions, all these things, and then you can design a good analytical approach, right? So this is one of the crucial thing in any business, right? Once they build the product, once they want to market, once they see the consumer reaction, the data science plays a crucial role, how best they can target the optimal set of consumers for their business, right? So this is important. Try to explore both data analysis and data science, because nowadays, given the AI era, people are expecting both the skills in one person. Primarily, sometime back we discussed, few minutes back, for data analysis, you can learn Tableau, Power BI, etc., and SQL. So this is the base for data analysis. So once you learn SQL, try to start exploring Python and PySpark as well. Yeah, so these two will give good hold. On top of it, of course, the quant part, like the ML, deep learning, and LLMs, etc. That we'll discuss in a while. But yeah, so try to become expert in Python. So you don't need to practice tons of code here. Given the GPT world, you can easily build the code. But only thing is, you should be in a position to understand and validate the code, whether the code is exactly pulling or preparing the analysis what you're actually looking for, right? So that's about data science, data analysis, and data engineering. Okay, so now we discussed the data science part, wherein they build the model and they check whether the model is, answering the business question. It could be like, what will happen to my, strategy? Like, let's say, suppose if I signed a campaign, how many or what sort of response I get, etc. Now the role is the ML and AI engineers. So please remember one thing, few organizations, both ML engineering or ML ops and data science are building the model and analysis, everything is done by one person, right? So it's a proper AI expert, right? Who can do data analysis, data science, ML, AI. Just try to understand the difference between, these roles. So try to get basic foundation of each and every role, starting from the data engineering till ML and AI engineering. This is very, very important given the way how AI is evolved, right? So these guys, basically the ML engineer or AL engineer, they take the models, whatever the data science team has built, and make them real. Like, for example, once you build data based on some trained data or test data, right? So you see how this model is actually working in a real time, right? So whatever you build using Python notebook has zero business value, right? The moment you deploy the model and monitor how the model is performing, and for every month, let's say it's a monthly prediction model, right? And every month how it is performing and how the model is actually handling the drift. Drift is, suppose if there's sudden change in the data or any random event happened, how your model is performing, right? So it should be reliable, right? The model should be reliable. So these guys try to bridge the gap between the experimentation and the production. Means whatever the data science team has built during the training phase, and now it is the real phase. So it takes the real data and give output on real time. So that is actually AI and ML engineering stuff, right? So on top of it, a few cases, we do have this AI engineer or prompt engineer. They primarily focus on this GPT world, right? Could be, OpenAI. So the Vertex AI, LangChain, Hugging Face, these are the top tools right now. VectorDB. So they handle all these things to build some Gen AI or maybe sometimes agentic AI systems as well. So multi-agent, single agent, right? So agent to agent interaction. So these kind of stuff they do build to the business problem. So if you want to become a agentic AI expert, for example, right? First you focus on the data science ML part, understand what are these models, how these models actually work in real world, and then try to get into NLP part. This is very, very important. Natural language processing, NLP. If you understand NLP clearly, then you can easily understand what is this Gen AI. Then you can build your own agent, right? So please try to make sure you're strong in foundations. NLP is the foundation. Before that, you should have basic understanding of ML and DL. Then you can get into this Gen AI and agentic AI space. Don't jump directly into agentic AI. So you may fail to build a nice agent or nice Gen AI system which solves the problem, right? So that is my suggestion here. That's about data and AI thing. We discussed about data engineering, data analysis, data science, ML ops, AI engineering, prompt engineering, and agentic AI stuff. So these guys primarily use Python, or if suppose they're directly, if you are, I mean, if your organization is, capable to acquire tools like AWS, etc., then there are nice services of Azure and AWS like Bedrock, etc. You can directly use them to deploy. Otherwise, you have to learn tools like, ML Flow. If it's a startup, also try to use this Docker, Kubernetes, Fast API, these kind of tools to deploy your models to build the ML ops pipeline, right? So that's about AI space. Let's move to the next one. Once you build the product, you know you tested, you build your model and you deployed it, everything is done. So now it's time to test the product. So the QA and testing. This QA engineers, they protect the system, whatever product, the digital product or any application, whatever the design team design and the build, the development team built, and the ML, suppose there is an ML involved in it, everything has been done, right? So these guys, they try to protect the system from failure. How? They test the logic, right? So this QA engineer or automation engineer, performance test, these guys, they test the logic, whatever logic is there in that, right? Edge cases. For example, there is a input of, let's say there is a X1, X2 inputs are there. Once you enter, there should be Y something as an output, right? If this X1, X2, if there is a range, if it is beyond the range, how actually the model is performing instead of failing. So suppose if it is giving a message, that is fine. Otherwise, if it is getting failed, there is something wrong, right? So these kind of edge cases, they do test performance, and when integration also they do test. This is actually performance testing. So in industries like banking or healthcare, a small bug can cause huge financial or legal damage. So that is the reason quality is not an optional. It is important. It's crucial. So once you build the product, you make sure that you do thorough testing. And these are the roles involved as we just discussed. And the tools, if you say Selenium is one very popular these days for automation testing, and there is a Postman is one tool you can test your if it is involving ML stuff, and there is one more thing called test ng. Selenium is primarily important. Also, these guys should have a basic understanding about development tools. Could be Python, Java, etc. Basic SQL, etc. So that it's good for them to easily understand the application. All right, the automation guys basically they create scripts. That is the reason I mentioned, right? If it is a data site related product or data product or ML product, they have to write some small SQL queries so that it picks up the data and run the analysis and test it. Right? So that's about testing. And these days, I think automation is very powerful. So try to have basic dev stuff, Python, SQL, etc. On top of it, Selenium, so that it's easy for you to become a automation tester. So let's move to the cloud part. So far we discussed the business strategy and the design part, right? The data part, testing, development, and testing, right? So now the cloud, so deployment. The cloud, I think most of you are aware of it. It's not a physical server. It is a server where you can actually scale up your requirement based on the volume, etc. Right? So that's a cloud infrastructure. The popular cloud softwares are like Azure, AWS, Google Cloud Platform, etc. Right? So what this cloud engineering is basically, so these guys manage the infrastructure. Imagine you build the product is a UI, for example, right, where a user enters some information and they get some insight about, let's say, health related stuff, right, or we discuss the smart app, right. So they input something related to their health conditions, etc., and it will generate some diagnosis, or after the diagnosis report it will generate some prescription. So this is at a high level. Now suppose, let's say, there are 1 million users logging in one time, or maybe in a span of 1 hour to 2 hours. So is your system able to manage that situation? Do you have such capacity to handle 1 million? It's called scalable. All right. Suppose suddenly thousands, millions of people are visiting your site. So can you handle that? So this cloud engineering is primarily focused on that, to make sure that the system can scale, recover from failures, and stay available when millions of users log in at the same time. This role keeps everything running. These guys have to make sure that the end-to-end product is running smoothly, right? So these are the roles like cloud engineer and platform engineer. So as I mentioned, there is AWS, Azure, and GCP, popular clouds. On top of these things, they should have skills about Terraform and Kubernetes. So the pipeline build and scaling up the pipeline, optimization of the pipeline, etc. Right. So for the deployment, this is uh, stuff they have to. So I have mentioned clearly here the infrastructure, scaling, availability, and disaster recovery. So very important, and very, very important, especially for the organizations who are data heavy organizations like banking, healthcare, because if a consumer is who rely on the platform, if suppose something happened, he may, I think you might have seen, right? Sometimes suddenly the banking systems gets failed, there is an error, you can't pay your Google Pay, for example, if you are using any UPI, right? So these sort of things happen because of some scalability issues. It happen, well, it happens, but the cloud engineer have to make sure that this is not happening. Now, that is the key role. So let's move to the next phase. Okay, let's move to this security and compliance. So the key roles involved in this phase, the security phase, is cybersecurity analyst, SOC, security operations center. IAM is basically identity and access management. So very important, what sort of roles, or access to be given to what sort of roles. Risk analyst. So this team basically, they try to protect the system from cyber attacks and any misuse. So they handle all these things, right? Authentication, access control, threat detection, and any incident response. Because compliance is key in any organization. Because especially the organization which is handling some data, users' data, so they have to make sure that the data is secured, stored securely, and also they're compliant as per the guidelines with respective governments, right? So these guys, cybersecurity analysts, they monitor unauthorized access and the potential breaches also. You might have heard sometimes saying, the data breach happened from so and so bank, and that is because of the cyber attack. So these guys, there are some tools and tech stack they use, and they try to identify if any attack is going to happen. They try to mitigate that, or they try to control that, right? So similarly, the security operations center analyst, SOC, they investigates the alerts, what sort of alerts that is sent by the security cyber security guys, and respond to the respective incidents. So key tools here, if you want to become a cyber security expertise, and you can actually learn Splunk, which is very popular, and then there are some IAM tools, identity access management tools. This is based on the respective cloud. All right. Then also there are few firewall systems you have to expertise. All right. And there is one more thing for SOC. It's called as CrowdStrike. Recently, it's becoming CrowdStrike is one, and there is Sentinel as well. So these are the few popular tools which actually helps cybersecurity team to use and make sure that the access is authorized and there is no potential, or there is no breach to the system. Very important function. And given the AI is also helping a lot to identify the incidents or alerts, right? So, yeah, that's about security and compliance. Now let's move to the operations. DevOps and SRE. So SRE is basically site reliability engineering. Okay, so these guys, they automate the deployment process and the monitoring process. So whatever we discussed so far, right? A product built, developed, testing, cloud engineering, everything. So each function they build and they do test. But these guys, they automate the entire process. So this will help to reduce the downtime. Suppose if there is a downtime, right? So there is a downtime because of, let's say, testing issue or because there is a development issue. So to reduce that, this automation is very, very important. There are some tools for DevOps also, right? You can actually use tools like Jenkins. If anyone want to become a DevOps site, this is GitHub Actions or their Docker, Kubernetes. So these are the popular tools, tech stack for any DevOps or SRE engineer. The SRE, some more tools are there, like the Prometheus is there, Grafana is there, and Datadog is there. So they ensure the system uptime and handle incidents in production so that customer don't see any issue in the real time. So that is the main things. Let me give a simple example so that you understand all these roles clearly, right? We discussed about developer, we discussed about cloud engineer, we discussed about DevOps engineer, we discussed about site reliability engineer. I'll give a simple example so that you will understand. Let's say you're building a house, right? So these guys, developer, they build the house, right? And the cloud engineer, they prepare and manage the land and utilities. Whatever land and utilities are required to build the house, they manage, and this development, the software developers, they actually build the house. Then these guys, the DevOps guys, they create the automated road that delivers new updates to the house. So for example, there is a road, so they create a road so that the new updates, so whoever, means it's a connectivity basically, right? And then this SRE, they make sure that house never collapses even during the storms. So there is certain measures he has to take care and has to discuss with both cloud and dev guys to make sure that this is not getting collapsed even during storms. Okay, this is a simple layman example. If I translate this to a business problem example, so these guys, the developer, so who builds the application feature, the product that user really interact with, right? And then the cloud guy, the cloud engineer, they manage the infrastructure where you are running the application. Could be cloud, AWS or Vessel, etc. Then the DevOps guy, this guy, he automate how code moves from one deployment to the production, right? So that is his role. Then SRE ensure the system stays reliable during any uncertain or any events, right? In the real world usage, during the real world usage, during any event, this should not get failed. That is the SRE rule. Okay, so hope you are clear with these rules because this is very, very important. And I hope you got clear understanding of different dev engineers roles. Let's move to the next one. So the operations and support. So once the system go live, like whatever build you have, the operations team, they takes the ownership. They continuously monitor the system health. They handle incident. They resolve customer impacting issues, right? So this is actually user support. Um, Quickly and effectively, right? So that is very important. You have to solve the customer's issue as soon as possible. So this is the stage where theory meets the reality, where systems prove whether they were built to scale, perform, and survive the real world usage or not. So they just don't fix the problems, they ensure that business continuity and protect customer trust, right? If I give an example, these guys resolve production issues, monitor system health, and provide ongoing user support to ensure smooth business functioning. Okay, So if development builds the system, these operations, the IT operations team, they keep the business alive. Okay. So the different roles involved, like L1, L3 support, application support, monitoring, but technically they do take care of these things. Predominant tools on this operations is one very important is ServiceNow. This is very important, and there is one more called PagerDuty. There is a new relic as well. So these are the few IT ops tools wherein you can see if customer raised any incident or any issue that you can see and make sure that you talk to the developer and make that issue get fixed. Right? So that's about IT operations and support. Every role is essential, right? Together they build a complete system. So no role is small, no role is isolated. All these roles together form a single system that turns business problem into a scalable digital solution. So always collaboration wins, right? We discussed the tech related roles and the tech part so far, like, the problem, design, development, data, integration, and cybersecurity. I mean, the cloud, SRE, all the stuff we did. So this is all related to the core tech, except that business and strategy part. And the first business and strategy part and the sales, marketing, and CRM tech. So these two are, more on the quality side. Okay. So whether you are designing a problem, you're validating your problem, you're designing a nice solution to your problem or not, versus this last part, this is how best you're marketing your product. Whatever the tech that you built, how best you're marketing, and are you reaching your consumers or not? This should not, the tech should not stop at delivery. They have to focus on the sales, CRM, and also the marketing tech. So these are the few roles in any IT industry. You might have heard about pre-sales executive, right? So that's about this one, sales, CRM, and these guys, they focus on acquiring customers, to retain the existing customers, and scale up the revenue, right? So how do you scale up? By retaining and to make sure that your customer is not churning or not attriting, right? So this tech directly drives the business growth here. So the sales engineers, they support the demos, the solution, and the technical discussions with the client. They no need to have the technical knowledge, but they should have an understanding. For example, if there is a AI product built, so they should tell to customer that what is the value that this product is giving. They don't need to, have ML or AI stuff which is involved in it here. That is about sales engineering, right? So similarly, the CRM guys, once the acquisition gets started, so they have to show the output to the leadership team, so CRM, right? So how best actually the marketing is happening, different campaigns are running, etc., etc. And also this is basically customer relationship management, and this is the marketing tools. There are so many tools right now, you can, the best is like Salesforce is one very, very important. Then HubSpot is one people are using, then Marketo. So these tools helps you to see what sort of tech the campaigns that you are rolling out and what sort of customers are getting acquired and how actually you are engaging your retention part. All right, these guys, they automate, marketers automate the campaigns and they track the leads and they personalize the outreach. So this is very important. Just now we discussed how data, tech, dev, all these things are important, right? On top of all these things, if you build a nice product, if you are not able to make this product reachable to the right audience, right consumers, then there is no use, right? So the skill set is primarily these tools you can easily learn Salesforce. The skill set is the smartness. And you have to be more creative and you have to come up with some innovative ideas to target with your consumers. See, this is at a high level, right? So far, whatever we discussed, all these roles are high level, but at a high level, broad 30 roles. But if you step in detail, if I take this example function, this sales marketing, there are people who actually design the ads, there are people who roll out the ads, there are third-party ads, tools, so many things involved, right? So similarly, each and every phase, data side or development side, there's so many other roles also kind of micro roles involved. Different organizations use different titles, but yeah, but at a high level, these are the broad, I could say, like 29 titles, which combines the complete ecosystem. When you connect all these roles, right? So a clear picture emerges, right? The last note, okay? This is my career insight to you all. Like, don't choose the role by trend. So everybody is saying Gen A, Agentic AI, LLMs and all. Directly, don't jump into it. So try to understand what is your strength first. So how do you, see yourself, strength and passion, right? So how you like to work, where you add most value. So this is very, very important, right? So first focus on that. Then the industry connect. This is really important. Like there are so many industries: pharma, telecom, oil and gas, banking, retail, e-commerce. So here, try to see what is your expertise, what is your domain knowledge. If you're already into IT, or if you are into different domain and you want to switch to IT, so ex I mean, spend time yourself, try to see where you can actually add value. That is very, very important. Business acumen multiplies value, right? So if you are already in an industry, try to get more deeper understanding and get more technical stuff to make sure that you're getting into a good role. Thank you so much. I hope you got clear understanding about all the tech roles which are exist. And just to add one important thing, given this Anthropic AI days, don't be scared about this Anthropic AI. So use AI or ChatGPT, these kind of tools to optimize your efficiency, right? Instead of taking 3, 4 to 5 days of programming, going through the code, etc., you can actually complete it in one day. But on top of it, you try to add more value by adding your expertise, your insights. That is very, very important. So if you're still confused which tech role fits you, this is my product. We recently launched Diti.ai. Please visit and see, go through the demo, how it works. And if you think you are in need of get some insights about this IT roles, please take the assessment and go through the report, which is like 10, 12 page report. Gives a lot of insights about your mind, understanding about tech stack and behavioral traits and soft skills, right? So in just 35 minutes, this is the one. On top of it, this is the channel, the mindrise.ai. And if this, please subscribe to this one. We will be coming up with series of videos wherein to educate people on business acumen, especially the industries like banking, healthcare. Each and every industry we discuss about the AI, capabilities. Like say, like suppose what sort of problem statements will be there, how AI will solve by industry. So that is where you can actually become expertise. Of course, I will be talking about all the tech roles as well in those specific functions or industries, so that it's easy for anyone who is already in IT to, adopt the AI. Instead of switching into AI, you can adopt the AI by learning additional skills which are required. Thank you so much. I know it's a bit lengthy. This is the first video. I thought, it's good to have this clarity, especially for the people who just graduating or graduated and who want to get into IT. So I hope you got something today. Thank you. Have a good day.